Okay, thank you very much for that kind introduction. Um, so today I will talk about multimodal comprehension using a human learning-centered approach. I will take questions, but what I'll do is that if I think that I'll be answering the question later, I'll just let you know, and that way we can be efficient with time. So just a couple of quick notes about SRI. So SRI is an independent non-profit research center. We work on various kinds of areas, including computer science, bio sciences and education. And you see some numbers here about, so one thing about us is that we spin off companies as well. So develop technology using government funding and then we spin them off. So these are some of our innovations. The innovation pertaining to the Center for Vision Technology is this, the 10-yard line in football. That was something that was invented at our lab, but there are a number of things. And this is a general idea of our organization. Then specifically within the Information and Computing Sciences division, we have the Center for Vision Technologies, and you see that we work on various aspects of computer vision, that include both real-time applications as well as offline applications. And in keeping with so you can see we are working on a number of ongoing DARPA projects, right? As well as other government projects. So moving right along now, let's get to multimodal comprehension. So what I'll do is that I will first set up the problem, try to even think about how one defines multimodal comprehension. And then the order will be that I will first, in fact, talk about an interesting, what one could think of as a side issue of how there can be bias in data sets, followed by a description of our approach to multimodal comprehension with large language models. And then finally, I'll describe some work that in fact we have been doing jointly with Professor Chris Kannan and his student Robik Shrestha, whom I assume all of you know. So let's jump right into the background and motivation. Incidentally, how much time do I have? Could you please tell me?
You have about 40 minutes or so for the talk and question and answer.
44. So I have about 35 more minutes. So
yes,
35 minutes. Okay, good. Thank you. Thank you. Just so I can plan accordingly. Thank you. So visual question answering is an active area of research. So visual question answering, just to give you some context here, like a typical paper from Hudson and Manning, the question is the tray on the top of the table black or light brown? And the answer comes back light brown. So many papers on this, but just to sort of jog your memory on this kind of topic. And there are various kinds of visual question answering. One is, subdivide the questions into different categories. It can be another task with different input, real image versus synthetic. There is also some work on testing consistencies in visual question answering. And there's a common sense visual question answering, and then there is a geometric question answering, graphical question answering, which I'll come to in a moment. And, Chris has been working with these two data sets, the Clever data set and the TDIUC data set. So why are we interested in the the graphical question answering. We're interested in this particular paper because what it does is it organizes all the questions in this kind of a graph, right? And the graph has various components. It has a pattern, program, reference. So the good thing about this sort of representation is that once you have come up with the representation, you can automatically generate a lot of variations of the question. So the worry that GQA had was that our typical question answering systems will tend to game the test, right, by just memorizing all the answers. So what you want to find out is that if I ask the question in a different way, but the essential question is still the same, does your answer remain the same or do you get deflected by that, right? So there's a lot of detail to this, but in short, just think of it as representing all this information on graphs so that from the graph you can generate a question in a straightforward fashion, right? So then here is the main question. So the main question is visual question answering the same as visual understanding, right? And the thing is that the approaches so far have all been statistical approaches. So I'm getting some noise. I think someone needs to mute.
Mute the microphone. Mine is muted. Okay, go ahead.
Yeah. So the approaches so far have been statistical, which means that basically the question answering system just memorizes the answers, right? And there is no notion of the relative difficulty of questions, which is what as soon as I got introduced to visual question answering, that was what I found to be the most problematic, right? Because you can imagine you are in a university, so you are very well aware, both students and teachers, that typically, when an exam is graded, you get more credit for the harder questions, right? And so, but that has not been happening much in the visual question answering literature, but that has begun to change. And so this GQA approach claims to guard against educated guesses and gaming, right? And it is not grounded. So the thing is, even that approach is not grounded in a science-based definition of comprehension. So what does that mean, right? So, so let me digress a little and tell you a little story. So I had actually bought a couple of books on reading comprehension for my daughter, and neither of us ever touched those books for whatever reason. And so she went off to college and I found these books in some corner of a closet. And I thought, well, maybe I should see what exactly she missed, right? And so I read these books and I was very surprised to learn that school teachers actually have a fairly computational view of comprehension. And so let me now tell you what that means, right? Now, there is one stipulation I want to make upfront, right? So I'm not saying that automatic multimodal comprehension techniques need to mimic what human beings do. I'm not saying that at all, right? But what I'm saying is that the results they achieve, if they are to claim that they are achieving comprehension, then the results at least should track what human beings do, even though you may use a completely different method per se, right? So the anthropomorphic approach gives you a science-grounded, graded approach to learning. So let's put up a straw man, right? So suppose you lay out a graded approach and you say, let's look at what grade I'm thinking about, first grade, second grade, third grade, right? And then compare that with the computational state of the art. So let me kind of break the suspense and basically say that the kinds of questions that kids are handling in first grade with picture books are way beyond any automatic technique at the moment, right? And this is very interesting. I want you to keep in mind that there are already papers out there that show how 10th grade physics can be answered using automatic techniques. So this is very interesting that 10th grade physics is manageable, but first grade story comprehension is still out of the reach. So basically, state-of-the-art competition is left in the dust very early, and that is because both the teacher and the students are human. So that's why I'm in the classroom, you have to be careful, right? But I just wanted to explain what the motivation was, right? And I just wanted to show this to you to explain to you why I think that the school teachers are actually very computational in their approach, right? So so you see what school teachers are making these kids do. They are making them actually write out what the key concepts are. They're actually making them what looks suspiciously like a graph, in fact, right? It looks like a semantic graph of the underlying story. So this is the point I wanted to make, that this is how comprehension is handled. So that then led us to our education group. I went to our education group and I said that, look, I have this kind of homebrewed knowledge now that I have picked up from these books. So what is the systematic science behind these kinds of things? And what they told me was that many years ago, decades ago, there was a paper from the applied psychologist Bloom, who talked about a taxonomy of learning objectives, right? And so you see now that at the lowest level is remember, right? So the sheer memorization is at the lowest level. Then you have understand, apply, analyze, evaluate, and create, right? So you can see that there's a hierarchy of skills. Now, there have been other versions of this taxonomy, and there are people who say, well, you know, this is too rigid a taxonomy and so forth. I don't want to litigate that type of thing. Our approach is just that there certainly is a hierarchy of skills. So just memorization is an easier task than understanding. And if you want to kind of get to the next level of detail, look at the verbs that are associated with each level of skill, right? So first is remember. So remember, look at the verbs: define, duplicate, list, memorize, repeat, state. So one way of dealing with this is what is done in the classroom, where children are asked, can you answer this question by just quoting from the story that you just read, right? Or can you at least just point to a part of the story that would help you answer that question? Whereas when you come to understand, you're already at another level, right? Describe, discuss, explain, identify, locate, recognize, report, select, etc. Apply is at the next level. So if I tell you a story about a child going from one city to another in a train, apply is what will happen if she were to go by bus instead of by train, right? Etc. So let's look at the state of the art. Where is the state of the art in this hierarchy? So the state of the art in the hierarchy largely occupies the remember part of this taxonomy. It does do a little bit of understanding, and I can explain that to you offline as to why I'm saying that. I don't want to go into that, and then interestingly, there has been some work that claims that they can actually generate advice, and therefore they are at the level of creation, right? So it's kind of very odd actually that you have claims that are at the lowest level of this hierarchy, and then you have a claim that is at the highest level of the hierarchy. So that is where now I should clarify that whatever they have, that claims to give automatic advice is nowhere near the kind of advice a human being would give. So, so that is in the way of background as to why. So in short, what we want to do is we want to be aware that there is a hierarchy of skills, right? And we want to know if we can use that kind of hierarchy to do a better job with understanding our content. Now let's do this. let's first.
Hello everyone, I'm Pratish Sahu and this is a joint work.
Oh,
with
sorry,
Hierarchies
I'm sorry. There's a problem here. I have to find a way to stop the, okay. So what we did was we looked at just the, we looked at what kinds of biases there might be in data sets, right? And so what we did was we worked with the.
Hello everyone, I'm Pratish Sahu.
Hang on.
Our focus is on procedural
Hang
multimodal.
on. I'm sorry. Maybe I can just do this. I'm sorry, there's an audio track and I'm not able to deal with the audio. I'll somehow deal with it. But the idea is that you have a recipe database, okay? So the recipe database has both pictures and instructions, as you can imagine, right? And your job is to answer questions. And the questions are like these, right? So these claim to address comprehension. So they are about, fill in the blanks, right? What would be the next image that would fit? Or which image is the odd one out in all this, right? Or what is the correct order of the image, right? So to give a very silly example, certainly you have to break an egg before you make the omelette, right? So if you show the omelette before you show the broken egg, you are out of order. So now the question is, can you come up with an automatic way to answer these kinds of questions, right? And the answer is yes, you can. And you can do that using statistical techniques. You can come up with fairly good accuracies for these things, right? So then what is the problem then, right? Why not just use the latest machine learning techniques, such as, say, transformers, and why not go from there, right?
Our focus.
So the answer
several
is,
challenges.
So the answer is this, right? There is a lot of bias in these kinds of data sets. So what do we mean by bias? So it turns out that you don't even need to train the classifier with the question and answer pairs, even if you just train the classifier with just the answers. The classifier goes ahead and gives a pretty good performance, right? So why is that, right? So
several challenges.
So why is that, right? So there are biases in the data set. So this is like, for example, a student hacking a test by just manipulating answers, right? So what happens is that if there is a lot of overlap between the questions, right, then somehow just by using the overlap between the questions, that machine learning is able to figure out the recipe details. Then another thing it also does is it figures out that the correct answer tends to be at a great distance from the incorrect answers. So if while conditioning you have made that kind of mistake, the machine learning algorithm is quick to seize upon those kinds of things, right? And then another thing that happens is that the correct answer is much closer to the question list compared to the incorrect choices. So in feature space, it turns out that the incorrect answers are at a much greater distance from the question then. So which means that you can see that the statistical learning classifier is answering these questions, but it is not actually answering the questions. What it is doing is it is using some kind of tricks and answering the questions, right? So this is something I wanted to point out because exploitation of these kinds of biases in a data set is not the same as comprehension. That was my aim of showing this work, right? And I apologize for this soundtrack business. So what we ended up doing was we prepared 3 control knobs to address these biases, right? So we, of course, proposed a novel hierarchical transformer-based reasoning method This method, I would argue, is not all that different from, whatever people have used with the transformers. I mean, and a hierarchy is called for because after all, there is a semantic hierarchy with recipes also, right? Recipes have ingredients, recipes have steps, and then there is the overall recipe that consists of the ingredients and steps, right? And the main contribution of this kind of work is the following. So this is something you may want to keep in mind in your work also, which is that it replaces the notion of a single test set with a cloud, as it were, around the test data set. So with these three control knobs, what we are able to do is we take a single data set, but then we are able to, for various settings, generate multiple data sets of progressive difficulty levels, right? And now the true acid test for any kind of system would be that it should do well regardless of all such manipulations, right? And so that is our
we list our contribution.
So that is our contribution here, right? And in the interest of time, I will skip ahead. I already told you how we organize, how this is multimodal data. So there is text and there is also visual information. And you see that we have this kind of a hierarchical setup where we have modality encoders, and then we have a scoring function. And so we are able to propose this hierarchical system. And it turns out that we, in fact, do outperform the state of the art, right? But the point I wanted to make was that we did that after we created a new data set in which we removed these kinds of biases, where you are just hacking answers using manipulation of choices. And you see that our HTRN beats the competing techniques. Here it's, and we are able to beat over all tasks, right? And so there are some details here which I will now, I will skip these
we use
details.
potato skin mini quiz just to come.
And you can see now, some of these things are easier than others, right? So distinguishing the correct, even for humans, it can be very difficult actually. So it is kind of difficult to pick the correct answer. You see in the middle one, it's difficult to pick the correct answer as to what, because they all look so similar to each other, right? And the hard one is also really hard. I at least found it very difficult to do this kind of thing. So that's just to give you an idea.
For more details, please
so that is on this part. So what was the main takeaway there? So the main takeaway there was that there are biases in data sets. And once you remove those biases in the data sets, because these are multiple choice questions, so once you remove the biases, it turns out that state-of-the-art techniques actually drop drastically in as to what comprehension is. So at least we have an answer. Comprehension is not hacking the answer choices, right? That is one part. So now the next question that comes up is, okay, so can you use this hierarchy to somehow assist in answering questions, right? So let's look at this now. So, trying to come up with automatic question answering systems is not new. Back when I was a grad student, which, I'm not proud to say was a couple of decades back, there was a system called ELIZA, and you could actually have a pseudo conversation with ELIZA. And today we have textualist models like GPT-3 that have 185 billion parameters. But here is what GPT-3 does when you ask it a question, right? So you ask it a question, you say, what happens when you mix cranberry juice and apple juice, right? So human beings will say, fine, go ahead and do it, no problem. But if you ask GPT-3, it thinks that you're going to die if you mix cranberry juice and apple juice. This is an experiment that I feel confident saying that you can try at home, okay? And I don't think anything is going to happen to you. So now the question is, why does this large language model GPT, why does this have this kind of impression? So we can only guess that because it has been trained on large amounts of text, it quote unquote read somewhere that mixing things is bad, right? And so it saw, it somehow figured out that there was some mixing going on, and it said that no, if you mix, you're going to die. So the question is, if there is this kind of problem, how do we solve it, right? So let's look at first some prior work. So prior work done by Vered Schwartz, I think this came out in the ACL conference. There is a notion of self-talk, right? So what you do is that before you jump directly into answering the question, you ask yourself some supporting questions. Now, isn't that interesting? That actually reminds you of the hierarchy I talked to you about earlier. So if you want to answer an understanding-based question, instead of directly trying to answer that question, first you try to answer some associated memorization-based questions, right? That is what you would think you should do, but it turns out that that is not what even this approach does, but at least it does self-talk. Now you ask a clarification question and you give it, you say, what happens if you sniff a mixture? It says you feel woozy. So even this self-talk actually still says that if you drink this mixture, you're going to die. So we still have a problem, right? So, but this begins to suggest what the answer could be. So the answer is that if you come up with a judicious selection approach to questions, right, to clarification questions, you might be able to answer these questions successfully, right? And so what we do is we ask a clarification question, is the cranberry grape mixture poisonous? And the answer comes back and it says that no, it is not poisonous. So once we add this clarification to the original question, GPT-3 now says that no, you can go ahead, you can actually drink this juice, there is no problem, right? So now note that there is no learning involved in this. So what we are really doing is, this could also be thought of as so-called prompt engineering, right? So what you are doing is you have this big model. You are not able to predict what this model does, right? I mean, most of the time it gets a lot of questions right, but occasionally it goes wrong. So is there a way you can give it a prompt or a hint to nudge it into the right place? So now let's quickly review the taxonomy I showed you earlier, right? You have remember, understand, etc. So we come up with a hypothesis. What we basically say is, we put forth this notion of what we call proximal context. So we say that if a question, say, is at level 2, right, which is at the understand level, the clarifying questions need to be at level 1 because that is the proximal context. Clarifying questions at level 3 are not going to be helpful, right? And likewise, if you're at level 3, you would use questions from level 2 to help you. Now, one problem, of course, we have is that if you look at data sets don't have these advanced questions. That is another problem. While people are quick to make big claims about these large language models, the challenge tasks out there actually don't stretch across this entire taxonomy at all. So they more or less stop at apply even the data sets, right? And so now I just told you about what proximal context was. So proximal context is whatever information exists at the next lower hierarchy level, right? And so that is why now what we said was, let's just find out whether the mixture is poisonous before we get to the next level. And so that is why now you see that with the new prompt, we are basically informing it that I'm going to drink a non-poisonous drink, right? And so now GPT-3 gets the fact that you are not going to die. So it doesn't say that you're going to die, right? Now, what we do is that we evaluate it over a bunch of data sets. There are various data sets. In the interest of time, I'll skip over the details of these data sets, but the names are, quite self-explanatory, right? You have a common sense, you have social interactions. It's about, what would people feel, etc., right? And so when you look at where these belong in the levels, so you see something like Vino Grande belongs at level 2, but common sense question answering belongs at level 3, etc., right? And so what we do is that we have the verbs, and therefore we have a certain set of question prefixes that we can use. And so which means that with the question prefixes, we can come up with the right prompts, right? And so we are able to come up with the prompts, and then once we come up with the prompts, we are able to actually show that we get good performance. And, we have done some interesting kinds of comparisons where we say, suppose you take GPT-2, which is a smaller model, right, than GPT-Neo, which is the public, which is the open source equivalent of GPT-3, right? It turns out that the larger model actually does a better job across the board. And in the interest of time, so what we are basically showing is, in these graphs, is that whenever we use the proximal context to prompt, we get better results than with any other kind of prompt. That is what we are basically saying over here. We have actually shown that, and we are also able to outperform the state of the art. Incidentally, that is another thing. And what we find also interestingly is that the larger models actually have clarifications that make more sense. So this is what I wanted to say, that we cannot make a blanket statement that these large models do not understand anything, right? At least based on our kind of work, it looks like as the model is increasing in size, the clarifications that you generate with the larger model actually make more intuitive sense. So here you see an example of that kind of thing, right? That GPT-2, is giving a very stupid clarification, right? The purpose of this, the secretary put you on hold because to prevent other further incidents from happening, which is just nonsense. Whereas the large model says that the main function of secretary is to keep the phone call short and sweet. So at least this is halfway related, right? To sort. So in conclusion of this part of the talk, what we did was we defined comprehension using a hierarchical description of skills, and then we operationalized this taxonomy using the notion of proximal context, which means that we said, well, we are going to use prompts that are from the next lower level of the hierarchy. And what we have shown actually is that we have outperformed the state of the art. Then we have also looked at how things perform across the sizes of models. And the advantage is that we are not doing any additional learning here. The work is all task agnostic, right? Because if you notice, we did not train anything. We're just using prompts and we're able to do this. So now, of course, in future work, we are looking at how to clarify the question generation, how to get to, get more challenging data sets that actually go all the way up the Bloom's taxonomy, and also test large models. So now, before you folks ask any question, I have a question. How much more time do I have left?
About 5 more minutes.
5 more minutes. Okay. So what I'll do is I'll breeze through this part very quickly then. This is what we have been doing with Professor Chris Kanan at RIT. And his graduate student, Robik Shrestha, has done a lot of work here, a lot of very good work. It's been a pleasure actually to work with Robik. And we have been cranking away. And so I have already described to you, what the limitations are and all that. So what was our aim here? Our aim here was to develop a new data set that truly tests multimodal comprehension, right? And so what we did was, and so what are ways we could do that? So what we are thinking is, why not have questions that are at every level of this taxonomy? So how would you generate those questions? And then what kinds of forms should those questions have? And how can you do that automatically to have an efficient data set creation? And then in the process, you are going to have new tasks and metrics that the state of the art will have to be advanced to address, right? So that is the overall purpose here. I've talked about all these things already, so I can skip all these things and go directly to what we are trying to do with the new data set, right? So just like children do, we want to ask questions about picture stories at different levels of Bloom's taxonomy. So we want to come up with a challenging data set, and we want to develop underlying graph representations, because if you have an underlying graph representation, you can automatically generate variations of questions very quickly, right? And that is so that then you can generate lots and lots of questions. And therefore, even though your core questions may be very few, you can generate a very large question set in a seamless fashion, right? So this was the part that I found to be the greatest fun, which is that we went out looking for open content on the web, which has Creative Commons license and all that. So we were able to find 2 sources, one out of India, other out of Africa. And there are some very nice stories there. Sometimes they don't have any caption, they're just pictures. Sometimes they have panels like these that I'm showing. And then, so there are lots of details of, what kinds of, stories and all this. And now our job becomes, can we extend this scene graph approach to story graphs, right? So can we have graphs at every level, right? And because the problem is that scene graphs are suited mostly for questions that are related to memorization. Another way of looking at memorization is to think of it as factual information. So you say, is there a little girl there? Is she holding a tennis racket? Those are all factual, right? But if there is some kind of interpretation, like, is she playing or is she actually only posing? That's an interpretation type question, which a human being will answer effortlessly, but an automatic algorithm will have a hard time answering that kind of question. So what we have done is we have come up with these kind of graph representations at every level of the taxonomy. So for example, let's go all the way up to level 5, right? So assess whether or not a certain character is some description, right? Happy, sad, or, energetic, right? Some kind of characterization, right? Or some kind of description. And so once you have come up with these kinds of graphs, then we have done a lot of work. So here, I have to give a shout out to Yunye Gong, who has done a lot of very nice work with how to train Turkers, because, it's very easy to get someone to say, is this an elephant or is this a giraffe? But once you start asking them these kinds of questions, life becomes quite difficult. But what we are doing currently is we have actually already made one round of data collection where we have question answers for each of the taxonomy levels that we showed you. And then there are lots of details then on how to filter out these questions, how to make sure the questions work well. And this is our question generation pipeline. And, arguably the most important part is to have a setup that can lead to automatic augmentation so that you can generate a variety of questions, right? And so a lot of work has gone into giving instructions to the talkers on how to understand, right? And so then new tasks and metrics come up, right? What are signs of true comprehension? So of course, answering questions at the higher levels of the taxonomy is harder. So that is a sort of an obvious hypothesis, but here are some not so obvious hypotheses. So just because you got the difficult question right, you should not fail on the easy questions. So you can also measure consistency at the story character level, right? And there are all kinds of consistencies here, and this is what we feel is our contribution now to the state of the art, which is that we are generalizing the notion of consistency going both bottom up and top down, right? So which means that if I get a difficult question right, can I get all the associated easy questions right or not? So girl was happy, and now I asked what was the girl doing actually, right? And I should not say that, oh, I don't know, but the girl was happy, right? And so now what we also do is we sometimes, we can also easily augment a question. So which means we take a question like, was the girl happy, and add another part. Was the girl happy and what was she doing? So your question answering system should not fail and say that I can answer whether she was happy, but when you combine it with what she was doing, I can't answer the question, right? So that is another kind of augmentation, right?
Ajay,
Yes.
Can we have 2 more minutes and we have questions?
Certainly, yeah. No, actually, it's interesting you should ask because this is pretty much, this is the last slide.
Oh, okay. Thank you.
So I'm glad, that's great timing. So in short then, what we have done is we have come up with a new set of consistencies that are across a single level, consistencies that are across multiple levels. And so what we want to do now is that a single data set in a very natural way will present all these challenges to any kind of automatic technique, right? And so we are going to develop a reference method, obviously, right? We can't just come up with a data set and then tell people, well, have at it. So we'll create a baseline technique and we'll show what kind of baseline performance there is. But what we want to argue is that these are the kinds of criteria that should be used to assess comprehension, right? So now in short, then to sum up the talk, let's go backwards. So first, last actually, we talked about a new data set that tests new notions of comprehension by looking questions along those skills and then testing for consistencies of a new kind, right? We also then in the previous part looked at how you can use the hierarchy to guide your clarification questions or prompting questions that actually help improve the performance of your question answering. And then in the first part, we showed how machines, because of their superhuman capabilities, can take advantage of biases that exist in data, right? And hack the answers, right? So you can see then that, in short, multimodal comprehension is a challenging problem. It has many dimensions to it. And yes, we have published the first part that I showed was published at WACV. The previous published at an ACL workshop. This work we plan to publish at ACL or EMNLP. And so this is in preparation, right? But you can see that this all this work just scratches the surface. There is much more to be done in the area of multimodal comprehension. So with that, I'd like to conclude my talk. Thank you very much for being a great audience and for